देखा जाए so metal alkyl compounds were the first organometallic compounds from where actually the organometallics has come into the picture. So it's a very easy metal alkyl, as the name suggests, there will be a bonding between metal and alkene bond. Yeah, alkyl आप समझती हैं CH3 group. या फोकस इस बात पे रखिएगा, there will be a single bond between metal and carbon. And those complexes used to be called as metal alkyl complex. Okay, so let us talk about some history. So in 1757, it's cadet. आप इनका फोटो देख पा रहे हैं. He is the first person who has made the first metal alkyl complex. उनका नाम था cadet. What he has noticed actually, one evil smelling cacodyl oxide he has formed. Very pungent smell used to become. And later on, he Robert Bunsen, आपने पढ़ा होगा Bunsen flame, same person. He told that the structure of cacodyl oxide is basically a bridging of oxolink with methyl arsenic complex. Okay, so remember the first alkyl complex is cacodyl oxide, which was coined by Cadet, and later on the structural prospect used to be defined by Robert Bunsen, and he told that the structure is bridged with oxolink. Okay, this is the reactions from which he has prepared the cacodyl oxide. So what he has taken potassium acetate and react with arsenic oxide, and then on refluxing it resulted the cacodyl oxide along with the side product of carbon dioxide and potassium carbonate. Okay, so first attempt, or you can say the first organometallic complex, was prepared by Cadet. As you know that there is some different of opinion about the organometallic compound in terms of metal alkyl bond and metal non-metal. For example, arsenic and all. That's why the people don't believe that this is first organometallic compound. But still, in most of the book, it has been mentioned that cacodyl should be a first organometallic compound. Anyway, we will talk about later on some more history. So, in the same continuation, if you will see, after 100 years, nearly after 100 years, the Edward Franklin has prepared one complex, and that is diethyl zinc. Right? In 1757, cacodyl oxide. And then in 1848, the next metal alkyl compound which has been prepared, and that is diethyl zinc. I would like to tell you one thing, that whatever the remarkable or noticeable discovery has been made so far in field of organometallics or any other field, you will notice that all those complexes are serendipitous. Serendipitous means they don't want to prepare that, but accidentally they prepared it. And after that, the chemistry has changed. Similar stories with diethyl zinc. You see what exactly the Edward Franklin was thinking, that if you will treat the zinc with ethyl iodide, then the ethyl radical will form. Right? His only motto to generate ethyl radical. But he was sitting in the lab and he was performing the reaction, and he noticed that a liquid product has been obtained. And then later on, he concluded that somewhere the zinc has been inserted and it created the diethyl zinc. And from here, the story of organometallics has started, or get popular, you can say. So remember 1757, then 1858. There are the persons who believe that the first organometallic compound is diethyl zinc. Right? Because zinc is a metal and direct bond with a carbon. And few scientists used to believe that no, it is a cacodyl oxide, which used to be a organometallic compound. Next. Later on, if you will see again after the gap of 50 years, Victor Grignard, you very well know that. He has prepared the Grignard reagent, which began to make a major impact through its application in organic synthesis. यहाँ पे एक चीज आपको बोलता हूँ. See, in 1900, the Victor Grignard has prepared the Grignard. Grignard आपको पता ही है क्या होता है, RMGX. ठीक है. I want to tell you one thing. If you want to prepare the Grignard right now in our lab, even I used to prepare in my research lab, you don't believe it's too tedious. Even a trace amount of moisture can spoil your whole reactions. We need to flame up the glassware first, then we need to cool it under argon, and then under argon we need to prepare the reactions, conduct the reactions. And you don't believe, once you will open the cap of the three neck flask or the glassware where you are using, a trace amount of environmental air will ruin your whole reactions, whole hard work which you have conducted. And just imagine he has prepared those many things in the 1900s. So really, I feel that it's a remarkable discovery, Grignard. And Grignard का क्या है कि in case of organic synthesis especially, I must say, most of the reactions, nearly 70 to 80% reactions which used to be carried out by 6 to 7 steps, by using the Grignard, those steps get reduced to 2 to 3. So means nowadays Grignard is like it's a god for organic chemistry. ठीक है. मतलब आप ग्रिग्नार्ड को इतना आसानी से लिख देते हैं ब्लैक बोर्ड पे या कहीं भी अपनी नोटबुक में कि इट इज RMGX. But once you will start making it in a lab, I'm telling you, it's a challenge. Still, it is a challenge. You have to clean the magnesium turning with the SCl. Then you need to dry it. Then you need to cool it under argon. And again, your solvent should be very much dry, right? If the water will be there, then magnesium will make magnesium hydroxide. So this way, it's a bit difficult. I just share this because don't think that whatever the compound you are writing on your notebook, it is as easy as you are writing. No, in the lab it is very difficult, especially Grignard. मैं बनाता हूँ इसलिए मुझे इसका बहुत अच्छे से आइडिया है. Even same way it is diethyl zinc भी bit difficult है, but ठीक है. So then in the same scenario, many more reagent has come into the picture, and these were associated with Slank and Ziegler Natta, you know very well. So Slank has prepared the organolithium, and Ziegler was preparing some organoaluminium compound, right? अब आप देख लीजिए जितने भी नाम I have mentioned on this slide, all the names are very popular. Whether it's a Franklin, you have heard about him, Victor Grignard, or the Slank and the Ziegler. You don't believe that on the name of Slank there is a lines. In my lab it is Slank line we used to call it, or Slank tube we used to call it, and means it is like an honor to him that to work on some hygroscopic or what you call air sensitive reactions. He has given a different type of glasswares, and those used to be called as Slank lines, Slank tubes, Slank flask, like this way. So it is an honor to which has been given to the Slank, because most of the air sensitive compound was prepared by him. Organolithium, of the organolithium is too sensitive, too sensitive. Even you don't believe, if you will destroy the organolithium in a water, it will catch fire, and sometimes there will be explosion also. And butyl lithium आपने सुना होगा, even butyl lithium इतना आसान काम नहीं है. इनको डिस्ट्रॉय करने के लिए मेथनॉल चाहिए, और मेथनॉल भी वाटर फ्री होना चाहिए, otherwise it will catch fire, and sometimes it create an accident, and the fatal accident actually. You see 1914 में बनाया है, जिसे आज तक हम डील कर रहे हैं. So in this journey, actually, many more complex has also been prepared, but these are the notable figures who have contributed significantly and drastically changed the prospect of the chemistry. That's why I have mentioned these 5 or 6 names. So again, I will summarize this slide that first organometallic compound is cacodyl oxide, prepared by Carrot. What he has done, he has taken the arsenic oxide and heated with the potassium acetate, and he resulted a compound cacodyl oxide. Later on, the 1848, it's a Edward Franklin who has prepared diethyl zinc, and in the same continuation, after the 50 years, of 1858. I think it's in 1900. The Victor Grignard has prepared the Grignard reagent. And later on in the same series, many more important organometallic compounds have been prepared. Those are organolithium and organoaluminium. The lithium compound used to be prepared by Slang and organoaluminium by Ziegler. चलिए आगे बढ़ते हैं. Here I have shown some stability pattern which used to be noticed with respect to the metal, right? So I have shown it, the bond with alkyl, the bond with aryl, and this bond with alkylide. एसिटिलीन होता है ना, आप इसे एसिटिलाइड बोल सकते हैं. हालांकि यहाँ पर R should be H in case of acetaldehyde, or you can say it's a substituted acetaldehyde. So M we need to find out, and we shall see that in what way the reactivity is going to be increased. अच्छा, चलिए बाद में बोलूंगा उसके बारे में. So now see, if you are moving left to right in the x-axis, left to right in the x-axis, you see, in this case, for example, in case of gold, right, nucleophilic reactivity is too less. चलिए y-axis पे अगर मैं एक लाइन खींचूं, फॉर एग्जाम्पल मैं यहाँ पे ले रहा हूँ, यहाँ पर गोल्ड है, ये x-axis पे गोल्ड है, राइट. इसके y-axis पे चलिए मूव करते हैं, तो ये यहाँ पर कहीं आता है. However, if you will compare the reactivity of sodium, now see where it used to become. It used to become here. For a while, we are talking about metal alkyl compound, right? So you can say that the metal alkyl compound which used to be derived from sodium metal do show the higher nucleophilic reactivity. Clear है? In compare to rest of the element, आपको show भी कर रहा हूँ, देखिए आगे जा रहे हैं आप. अभी देखिए इसके रिस्पेक्ट में न्यूक्लियोफिलिक रिएक्टिविटी इट्स टू हाई. However, if you will compare with the gold, it's too low. Okay. Similarly, if you will move from sodium to magnesium, magnesium to titanium, then copper, then platinum, and then gold. So at the end, gold used to be. So the complex which has been derived from the gold metal alkyl complexes show the poor nucleophilic reactivity, or you can say they are very stable. Okay. But metals which used to be derived from S block element especially, they do have higher reactivity, and that's why they do used in case of organic synthesis. Okay. चलिए, तो ये पैटर्न दिखाने का यही है. और याद रखिएगा, द नेचर यूज्ड टू बी ऑप्टेड अ लीनियर प्रोस्पेक्ट. कुछ ऐसा नहीं है कि डिफरेंट लीनियर मतलब आप समझिएगा, इफ यू आर मूविंग फ्रॉम सोडियम टू गोल्ड, they are going to decrease in a linear fashion, है ना, abrupt nature नहीं आता. खैर देखिए, reactivity used to be depend on so many other factors also. For example, it used to be depend on oxidation state as well as the availability of other environmental conditions. So in that case, during drawing this graph, we are considering that those many things are same, है ना, otherwise तो comparison ही नहीं कर पाएंगे आप. ठीक है. तो अगर कोई पूछे देन, अच्छा यहाँ पर एक क्वेश्चन आता है, व्हाई इट इज सो, व्हाई दिस बिहेवियर हैज बीन ऑप्टेड, कि प्लैटिनम के केस में लेस रिएक्टिविटी है, न्यूक्लियोफिलिक रिएक्टिविटी है, और सोडियम के केस में हायर न्यूक्लियोफिलिक रिएक्टिविटी. आपको बता दूं कि ग्रिग्नार्ड यूज्ड टू बी केप्ट इन आर्गन एटमॉस्फेयर ओनली, है ना. एंड द मोमेंट यू विल ओपन द ग्रिग्नार्ड एंड सपोज ग्रिग्नार्ड इज ट्रीटेड विद वाटर, it will create an explosion, and sometime the glassware is going to be broken. Highly exothermic reaction used to be happen. Similarly, I told you that in case of butyl lithium also, it's a highly reactive. प्रोटॉन obstruction के काम पे आता है. आपको ये सब तो बताया ही होगा, ऑर्गेनिक में ये आप बोलते हैं, है ना. तो can anybody tell me why this type of behavior used to be noticed? Can anyone? Means in short, अगर देखा जाए तो यहाँ से एक कंक्लूजन ये आ रहा है कि the metal which used to have a higher electronegativity, they do have a lower nucleophilic reactivity. हाँ, यही तो है ना. The metal which used to have a higher electronegativity, they show the poor nucleophilic reactivity. बताइए व्हाई इट इज सो. ये सब ग्राफ इज ओके.
across
Can anybody
the
tell me why this type of behavior used to be?
along the period electron density
चलो कोई
increases.
प्रयास तो करिए. एनीवन. क्या हो गया भाई, कोई बोलता ही नहीं है यार. एनीवे खैर छोड़िए, अब मैं बताऊंगा नहीं, आपको खुद से फाइंड आउट होना होगा. इट्स इम्पोर्टेंट. हाँ, सो जस्ट फाइंड आउट. अगर आप बोलेंगे नहीं तो कैसे होगा. देखिए ये मैंने आपको बोल ही दिया कि सोडियम के रिस्पेक्ट में एम एथिल को देखिए और प्लैटिनम के रिस्पेक्ट में देखिए. चलिए खैर, नाउ वी शैल टॉक अबाउट सम कैरेक्टरिस्टिक ऑफ स्टेबल मेटल एल्किल कॉम्प्लेक्सेस. यहाँ से एक चीज कंक्लूजन होती है, वो मैंने आपको बोल दी है. इफ द इलेक्ट्रोनेगेटिविटी ऑफ मेटल विल बी हायर, then their nucleophilic reactivity will be poor. That's I want to convey it from here. I want to know the reason actually, but since I have not heard from you, so it's okay. ठीक है, चलिए. So next thing is that what type of characteristic is required to isolate the stable metal alkyl complex. देखिए जब भी Grignard की बात कही जाएगी, remember Grignard is highly reactive, means it is unstable in nature. Similarly, the N-butyl lithium, it is highly reactive, है ना? If it is highly reactive, it means that it is unstable in nature. Did you get my point? So what exactly the characteristic should be present for the stable metal alkyl compounds to have the kinetical stability, right? Chaliye. Remember, one feature which should not be present is the elimination, beta elimination pathway. Means if the proton is available on the beta positions, then there will be a pathway to further divide it or further disintegrate into the some other configuration. So always, if you will try, if you are preparing these complexes, you need to make sure that the beta carbon should not have any hydrogen attached with it. ठीक है. अब देखिए, मैंने पहले ही पॉइंट लिखा है, alkyls that have no beta hydrogens. Alkyls that have no beta hydrogen. अभी मैं बोलूं hexamethyl tungsten compound है, right? In this case, if you look, the beta position is not being present, so there is a no possibility for to disintegrate this complex or decompose this complex. Similarly, if you will bond with the what you called, it's a benzyl group, right? So it's a tetrabenzyl titanium compound. In that case, titanium 4 है. So here, if you will see, this carbon is alpha and phenyl is basically beta. And if you will draw, the phenyl means benzene ring, right? But in that case, the beta position from where the CS2 group is attached, right, that particular carbon will not have any hydrogen. So in that case, in this case also, there is a no available beta hydrogen. That's why these complexes are stable. So one feature which is very important about the metal alkyl compound is that there should not be any beta hydrogen available. Second देखते हैं, the alkyls for which the beta hydrogen is unable to approach the metal as a result of geometry or bulk of the ligand. इसका मतलब ये है कि कुछ एक ऐसे भी केसेस होते हैं जहां पर इतना बल्की ग्रुप हो जाता है कि it is very difficult from that particular alkyl group to get coordinated with metal center. That case also, for example, यहाँ पे देखिए बहुत सारे लिखे हुए हैं. अब जैसे बोला जाए मॉलिब्डेनम का, ठीक है. Now see alpha and this is beta. If you will see, if you will expand this basically, so molybdenum is too far from this carbon, so it is really been difficult to abstract this hydrogen because metal hydride complex बनाते हैं ये याद रखिएगा, right? So for to the abstraction, the proton abstraction from this particular carbon is bit difficult because the distance of this carbon with molybdenum is too far. अच्छा ऐसा क्यों है? Because always remember there is a presence of double bond. डबल बॉन्ड जब भी प्रेजेंट होता है ना, तो आप ये रखिएगा मूवमेंट ना हिंडर्ड हो जाता है. जैसे सिंगल बॉन्ड के अराउंड ना यू कैन मींस द मॉलिक्यूल कैन रोटेट अराउंड द सिंगल बॉन्ड, but it cannot be possible with respect to double bond and triple bond, because you might be knowing that there is the double bond formation involves the lateral overlapping. That's why it frees or it hinders the rotation along the bond. That's why the abstraction of proton from this carbon through the metal is going to be a bit difficult. So in this case, basically in most of the cases, the presence of double or triple bond will help to stabilize the metal alkyl compound. अभी इसमें भी देखिए PS2 अगर आपने किया है, so it's not possible to abstract the proton from phenyl ring. Why? Because it is already stabilized, and the moment you are trying to abstract the proton, basically you are making the phenyl ring unstable, and that is not possible because it is stabilized with resonance energy. So this way, this example has been mentioned over here. ठीक है, चलिए थर्ड, the alkyls in which MCCH unit cannot become coplanar. अच्छा, coplanar का मतलब आप समझते हैं? See, क्या होता है कि जैसे if you want to abstract the proton, the orientation of the metal and proton should be in the same plane. Suppose if the proton is lying in opposite plane, in that case the angle is going to be 180. मतलब एक random approach लीजिए, it will be for example अगर trans configuration में चला गया तो it will be 180. Now again the same point 2 आ जाएगा कि it's unable to approach the metal now. That's why in that case also the proton abstraction will be difficult task. So there should be a coplanarity for the hydrogen abstraction from the alkyl group, and if it is not, then metal alkyl compound will be stable. Next, an 18 electron species with formally bound ligands which will not dissociate to generate vacant. अब इसका मतलब क्या है? देखिए, जैसे आपको मैंने बोला stability used to be defined with respect to what? With respect to 18 electron. And suppose the complex which you used to have is already achieved the 18 electron, and by abstracting the proton it will lose the stability, right? In that case, always remember there will be a no dissociation. Why? Because by abstracting the proton, if the resulting complex is going to be unstable, why this process will happen? नहीं होगा ना. अगर 18 से कोई चीज 17 पे आ रही है तो बाय नेचर दैट पर्टिकुलर थिंग, मतलब स्टेबल को अनस्टेबल करना उतना आसान नहीं है. दैट्स व्हाई इन दोस केसेस द डिसोसिएशन इज नॉट बीन नोटिस्ड. अब यहाँ पर कुछ एक एग्जांपल दिए गए हैं. यहाँ पर देखिए सीपी रिंग है, ठीक है. तो एक सीओ कार्बोनिल के दो अटैच ऑन आयरन, एंड द नेक्स्ट इज CS2CS3, है ना. अब देखिए अगर बात करूं तो सीपी कितने इलेक्ट्रॉन देगा? 5. 1 CO2 तो 2 कितने देंगे? 4. तो 5 + 4. And if there is a direct bond with the iron and this alkyl group, then only 1 electron will be contributed. तो 5 + 4 + 1 कितना हो गया? 10. आयरन के आउटर मोस्ट में कितने इलेक्ट्रॉन होते हैं? कोई बताएगा या वो भी छोड़ दूं मैं? Anyway, 8 electron होता है. So basically this particular compound is following 18 electron rule. And now if you will look that there is a probability of beta hydrogen, and if one proton is going to be abstracted, what would be the result? It will be CS2 double bond CS2. So in that case hapticity is need to be changed. यहाँ पर तो डायरेक्ट बॉन्ड हो रहा है, उस केस में कुछ तो और बनाना पड़ेगा. तो बेसिकली अगर नहीं बनाया तो क्या? So in that case, the probability is that your 18 electron compound is turning to be get unstable. That's why this cannot be possible. Similarly for this also, mostly hapticity जहां पर भी आती है उसके केस में proton abstraction is not easy task. ये तो हाइड्राइड ही है. चलिए next, in case of D0 alkyl complexes, see if the metal configuration is D0, then also the proton abstraction will be difficult. वो नहीं हो पाएगा. ठीक है, चलिए. तो आपको ये याद रखना है 5 कैरेक्टरिस्टिक है. पहला, in the usual practice the alkyl should not have a beta hydrogen. The second thing is that for beta hydrogen is unable to approach, then the result of geometry or the bulk of ligand. Any of these two may help not to dissociate, And the third, there should not be a coplanarity, then also there will be a no obstruction. The fourth, 18 electron species with formally bound ligands which will not dissociate to generate the vacant, and some D0 alkyl. Okay, now we will move towards the preparation of alkyl. So four prominent preparations are reported. One is nucleophilic attack on the metal. Another is electrophilic attack on the metal. Third is oxidative addition, and the fourth is insertion. So these are the four prominent methods which used to be applied to prepare the metal alkyl complex. ठीक है, पहला और दूसरा देखिए एक दूसरे के अपोजिट है. ठीक है, चलिए we will work it on one by one. Again, remember, four prominent procedures are reported for the preparation of metal alkyl complexes. One is involved the nucleophilic attack on the metal. Another is electrophilic attack on the metal, oxidative addition and insertion. चलिए, ये देखिए पहला एग्जांपल दिया हुआ है, right? If hexachlorotungsten will treated with lithium and butyl lithium बोलते हैं ना, तो n methyl lithium, then what would be happen? We will result to metal alkyl complex. ठीक है, WMe whole 6 plus lithium chloride. Very straightforward reaction is there. Lithium will abstract the chloro, and Me will be get coordinated with W or metal, you can say. So I hope आपको यहाँ से तो clear होगा कि in this case basically lithium will be plus. देखिए lithium ये methyl lithium itself is a metal alkyl complex. स्लैंग ने ऑर्गेनोलिथियम कॉम्प्लेक्स बनाए थे, एक्चुअली मैंने आपको बताया भी था. तो दिस पर्टिकुलर कॉम्प्लेक्स इटसेल्फ इज मेटल एल्किल कॉम्प्लेक्स. सो व्हाट वी यूज्ड टू डू, इसके केस में आपको पता होगा मेथिल के ऊपर क्या चार्ज आएगा, माइनस चार्ज आएगा, और लिथियम के ऊपर क्या चार्ज आएगा, प्लस चार्ज आएगा. Similarly, if you will make it here, chloro will carry on minus charge and W will carry on plus charge. So now what would be happen? Plus को plus से plus को minus से आप वो कर दीजिए. So lithium will take the chlorine because it's ionic, and rest of the moiety will be get combined. It is WMe6. Similarly, if you will treat dimethyl zinc with NbCl5, ये देखिए, then in that case also you will be able to metal alkyl compound. चलिए दूसरी बात करते हैं. For example, an electrophilic attack on the metal. Here we have taken one example of pentacarbonyl manganese, which I am treating with methyl iodide. Will result the metal alkyl complex. इसमें देखिएगा there is a bond between methyl and manganese. That's why this compound is metal alkyl. अच्छा, यहाँ पर याद ये रखना है कि this particular reaction belong to electrophilic attack on the metal. Similar pattern, this reactions I have shown it with respect to iron also, and similar the same as if one CO will be get removed from here, यहाँ से हट गया, right? Then direct bond will be formed between manganese and trifluorocarbon. Then again it is organometallic compound. ठीक है, इसे शायद मुझे याद नहीं है, कोलमान रिएजेंट बोलते हैं, ठीक है. और ये आई गेस कहीं तो आया है, इस फॉर्म में नहीं आया था, सोडियम के फॉर्म में पूछा था या CH3 के ही फॉर्म में था, आई डोंट रिमेम्बर. इन नेट में पूछा है या गेट में किसी एग्जाम में पूछा है 2008 के आसपास, अगर मैं सही हूं तो. So this particular example has asked, actually it has asked in different way, but same answer used to become, it is MEMnCO whole 5. Next procedure is oxidative addition. What is oxidative addition? As the name suggests, there will be an addition followed by oxidation of central metal. For example, अगर मैं यहाँ पर बोलूं तो इरिडियम की ऑक्सीडेशन स्टेट है +1. ठीक है, इरिडियम की ऑक्सीडेशन स्टेट क्या है, +1. आफ्टर द एडिशन ऑफ दिस मेथिल आयोडाइड, अगर मैं इरिडियम की ऑक्सीडेशन स्टेट निकालूं तो देखिए हो गई है +3. कैसे? वो ऐसे हो गई कि इरिडियम विल बी गेट कंबाइंड विद आयोडीन एंड इरिडियम विल गेट कंबाइंड विद क्लोरीन. दो हो गए और एक मेथिल से. डोंट बी गेट कंफ्यूज, आई विल ड्रा दिस. देखिए, इसको मैं ड्रा करने की कोशिश कर रहा हूँ. ये लिखा ऐसा है, but actually it is like iridium bonded with iodine bonded with chlorine bonded with methyl bonded with CO bonded with L, right? तो oxidative addition के केस में क्या है? The coordination sphere as well as the oxidation state should be increased by 2 units. So if you will see here in this case, the coordination number is basically 4, but here the coordination number is 6. So we can say that the 2 unit increment has been shown in the coordination sphere, right? So one feature has been followed. The second is the oxidation state. Now see, in this case, the oxidation state is +1, है ना? अब देखिए, we are only taking the contribution from chloro. Rest of the ligands we are considering these are neutral. तो अभी देखिए, ये पहले से है, ये भी पहले से है, ये भी पहले से है. So these three will be neutral. So which they are going to contribute 1, 2, and 3. So in this case, iridium oxidation state will be +3. Earlier case, iridium oxidation state is +1, and in this case, iridium oxidation state is +3. So basically, in the coordination number as well as the oxidation state of the central metal has increased to +2 unit. That's why this reaction used to be called as oxidative additions, right? So in case, अब देखिए यहाँ पर bond भी है iridium और methyl का, so this particular complex will be called as metal alkyl complex. Fourth is PTL4 untreating with the methyl iodide. ठीक है, यहाँ पर भी आप देखिए the bond has been framed between platinum and methyl. That's why this complex will be metal alkyl. It is also oxidative addition route. Next is insertion reactions. So insertion reaction, as the name suggests, your particular incoming ligand get inserted. And remember, in case of insertion, there will be a no change in the oxidation state. अभी देखिए यहाँ पर PTPSCl लिखा हुआ है, तो यहाँ पर ऑक्सीडेशन स्टेट प्लैटिनम की जो है वो +2 है. क्या है? +2 है. कैसे? बिकॉज ऑफ हाइड्रोजन एंड क्लोरीन. एंड आफ्टर द इंसर्शन ऑफ दिस एल्कीन C2H4, what the compound is going to be framed? You see, one because of this alkyl and one because of this chloro. Still it is +2. Is there any change in the coordination number? No. So the nature of reaction will be insertion. ये क्या आएगा? +2. ठीक है, अभी क्लियर है ना? C2H4 आया, देखिए सब हो गया. तो क्या होता है, बेसिकली C2H4 has come in between of platinum and hydrogen bond, और उसने क्या बना दिया? ET. C2H4 में H जोड़ दिया, C2H5 हो गया. That's why this is insertion reaction. Similar reaction has been noticed in case of molybdenum hydride complex, where diazomethane has treated, and now what would be happen? This hydrogen will combine with CS2. That's why it reacts CS3. So these four prominent procedure used to be opted for the preparation of metal alkyl. Actually, there are the many more, but these are the four method which used to be applied for metal alkyl complex preparation. That's why have been mentioned here. One is electrophilic, another is nucleophilic, third oxidative, and fourth one is insertion. Chile. So now we will study some chemical properties. So one is basically, यहाँ पर देखिए मैंने metal hydride लिया है for to represent it. Now see, this is a metal hydride complex, right? I'm treating with sodium hydride, again metal hydride ही है. अब देखिए क्या हो क्या रहा है यहाँ पर, एक H जो है यहाँ से S6 से एक H abstract होती है, और वो H इस H के साथ कंबाइन होके S2 के फॉर्म में निकल जाती है. The moment you will remove the H, right, what the charge will come? The charge will become minus, and you know the compound should be neutral. That's why sodium will become outside the coordination sphere. Clear है? चले, now hydride transfer पढ़ लेते हैं. इस केस में भी देखिए जिरकोनियम हाइड्राइड लिया है मैंने. When it will be treated with formaldehyde, what would be happen now? Now see, it itself get combined here, and it will make OCS3. ठीक है. सॉरी. देखिए CS2O के साथ करेंगे तो OCS3 बनाएगा. लास्ट वाला भी देखिए, इसके केस में यहाँ पर रेडिकल जनरेट हो गया. खैर, these reactions